this video, I shall discuss about the Bitonic sorting network onto the unordered input. Up till now, we have discussed the Bitonic sorting onto the um, onto an input which is already into the Bitonic sequence. But here, our aim is that we want to sort the input if it is in some arbitrary order. It can be into the ascending order, descending order, or any unordered order. So in order to assess this particular situation, we have to assume the um, we we cannot be able to follow the same step that we have followed with respect to the Bitonic merging. In the case of the Bitonic merging, um, it is being required that the input should be into the Bitonic sequence format. But if the input is not into the Bitonic sequence format, then we have to uh, then how to proceed. So it is the purpose of this video. So for an irregular or unordered input, we have to follow this particular strategy that we have to repeatedly merge the pattern sequences of increasing lengths. That we have to start working on the two elements. Suppose the number of the elements are n. So I have to pick only two elements into the whole list, into the whole sequence. Now those two elements uh, are to be checked whether they are into the ascending order or into the descending order. And with respect to that, we have to convert into the ascending or descending order. For example, it is the of the Bitonic sorting outline of the Bitonic sorting network, which is showing the four different stages. These are the four broad stages. These are the four broad stages. It is the first broad stage 1. It is the second broad stage 2. This is the third broad stage 3, and this is the fourth broad stage 4. The reason I'm saying that these are the broad stages because uh, because because these broad stages in some of the cases um, comprises of the multiple sub stages. For example, we have earlier discussed about this particular step into the last video that this particular Bitonic sorting network that when we have to do the Bitonic merging, that when we have to do the Bitonic merging of a Bitonic sequence in which the first half into the ascending order and the second half into the descending order, then then we have to perform the splitting operation four times, because logarithm of 16 is basically 4. So we have to do the so we have to perform the splitting operation four times, and in those four times and in those four times the uh, it should be done with respect to the four different columns of the Bitonic merging into the sorting network, and then we can be able to get the final sorted output. Now, this same methodology is being divided into the multiple into the elements at the elementary level, such that we shall start doing the Bitonic merging for every two elements. For the first two elements, we will perform the Bitonic merging. Then for the next two elements, we will perform the Bitonic merging into the stage 1. Then then for the next two steps, we have to perform the Bitonic merging into the stage 2. Then into the stage 1. Then we have to perform the Bitonic merging onto the next two elements. So in this same step, we have to start working on only two values and arrange them into the either into the ascending order or descending order. So with the help of the increasing comparators, we have to take the two values as the input and arrange them into the ascending order output. Similarly, for the next two elements, we have to take two elements as the input and convert them into the descending order. So in this way, when these four values will be obtained, then those four values are acting as a Bitonic sequence, because because we know that Bitonic merging operation used to take place onto the onto the Bitonic sequence. So the input should be into the by default into the Bitonic sequence format. So when these two when this first Bitonic merging will take place, it will generate a monotonic increasing sequence of the two elements. With respect to this next two elements into the stage one, it produces the next two elements into the reverse order stage. So in this way, we have the monotonically increasing sequence as well as monotonically decreasing sequence. So it is a Bitonic. So it is a Bitonic sequence with respect to these four values. Now with respect to these with respect to these four values, um, we have to we have to apply the increasing of the comparators only with respect to this particular step of the stage 2. Now with the help of since we are using only increasing comparators, then then with the required splitting, we are able to get a sorted output. Now in the same way, here now here we have generated with the help of this particular increasing comparators is sorted output, and with the help of this increasing comparators we have generated a decreasing output. Now when we will provide this Bitonic sequence, because I explained earlier that the Bitonic that for having the Bitonic merging operation, we need a Bitonic sequence. So first two inputs are into the ascending order, and the second two inputs are into the descending order with respect to this particular step. So here, when this Bitonic sequence is taken as the input, then the next then it will generate a descending order output with respect to this particular step. So in this way, we have four values into the ascending order with respect to this particular step, and we have four different values into the descending order with respect to this particular step, and which will be applied, which will be given as an 8 element input, in which first four elements are into the monotonically increasing sequence, and the next two elements are into the monotonically decreasing sequence to this particular part of the Bitonic merging. So it will arrange them into the ascending order. Similarly, the output generated by it as a descending as the Bitonic sequence is being converted by this particular Bitonic merging process into the descending order. I shall explain it into the detail into the next few slides, but I'm just giving an overview that our idea is that two elements of an input are by default into some particular are by default into some sort of sequence, monotonically increasing sequence or decreasing sequence. So we can be so those two elements can so those two elements initial elements can be assumed as it is into the Bitonic sequence format, and by applying the suitable Bitonic merging operation, we can be able to convert them into the ascending order or descending order. So we can deduce from the figure that each stage of the network merges two Bitonic sequences. That here each stage is merging two Bitonic sequences, one into the ascending order and another into the descending order. So it is merging two different Bitonic sequences, ascending and descending order, and convert them into the ascending order. Uh, Now, so the general idea is that for any unordered input, we have to perform the following operation. We have to first of all convert it into a Bitonic sequence, and then generate the sorted output with respect to the Bitonic sequence. So with respect to this particular idea, uh, either I have to generate the sorted output in the sense that into the ascending order or into the descending order. We can interpret above for each step of the Bitonic sorting network as take an input in the form of Bitonic sequence and generate the sorted output. Um, we shall now understand it with the help of an example. That earlier I provided an outline of the process. Now I will give the detailed process. Now before moving further, remember that this whole thing is to be performed with the help of the increasing comparators and the decreasing comparators. So this particular figure is with respect to the increasing comparators, and this with respect to the decreasing comparators with the circle negative and the circle positive. Now, uh, as I explained earlier, any sequence of length 2 is the Bitonic sequence. I have explained it earlier that any two elements are into by default into some Bitonic sequence because those two elements are either into the monotonic increasing sequence or monotonically decreasing sequence. Well, and with respect to our requirement, we can be able to convert them into the increasing into the sorted order or into the descending order by the usage of increasing comparators or the decreasing comparators, and then a Bitonic sequence of length 4 is being built that with the help of two elements with the help of two elements um, of with the help of the two elements at here we have generated a ascending order or the monotonic increasing sequence, and with the help of the next two elements we have generated a decreasing sequence. So in this way a Bitonic sequence of length 4 is being generated. Bitonic sequence of length 4 uh, is being generated, which will be provided as an input to the next four um, as a Bitonic sequence to the next stage of the Bitonic merging. Now, when we got this four length sequence, then then we have to repeat the same step to generate a larger Bitonic sequence. Now, it can be understood more easily with the help of this particular example that we have a random input. We have a random input in which the value 10 is there, then 20 is greater than 10, then 5 is less than 20, then 9 is greater than 5, then 9 is uh, greater greater than 5, then again 3 is lesser than 9. So in this way, this whole input, this vertical input is into some random order. It is not into the form of a Bitonic sequence or into some other sequence. So when we will start with this point one ideology that any sequence of length 2 is into the Bitonic sequence, that if we shall assume that these two elements are into the Bitonic sequence, then we cannot be able to deny it, because these two elements are into the monotonically increasing sequence. So if we will apply the increasing comparators on it, then it will remain unchanged as the value as 10 and 20, as the 10 and 20. Now, for the next two elements, which are also into the Bitonic sequence of monotonic increasing format, when we will apply these two elements for the decreasing comparators, then uh, then a decreasing then the output is being generated into the descending order, that the first two values are in the 10, 20, and 9, 5. So now with respect to these four values are being provided as an input towards the next uh, towards the next Bitonic merging operation, such such that after such that we 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 know that the Bitonic merging operation used to take place onto the logarithmic of number of elements. Since we are providing these four values uh, simultaneously to a Bitonic merging network like this, so it will divide the input into two different parts. This particular line is showing the first split. So with the help of this first split and the subsequently working onto a single element, these four values 10, 20, and 9, 5 are being arranged into the sorted order as 5, 9, 10, and 20. Similarly, this the next two elements 3, 8 are into the ascending order, and the next two elements are into the descending order, or the monotonically increasing sequence and the monotonically decreasing sequence. When these four values are being provided as an input to the to this circuit negative binomial merging operation with respect to these four elements, then only one split will take place, and it will and after the completion of this whole process, it will generate them into the descending order as 14, 12, 8, 3, as 14, 12, 83, it has been generated um, because um, the elements have been generated into the reverse order, because we have assumed that the comparators are the decreasing comparators, and in this way and in order to provide as an input towards the third broad stage, which comprises of the three sub steps or the sub stages. Now now we have to the four um, four, the four intermediate output at this place and the four intermediate output at this place. So in total, the eight elements are being provided as the input towards this particular Bitonic merging operation. Towards this particular Bitonic merging operation. Now since there are eight elements, so the logarithmic of eight shows that there should be there should be there should be three splits, such that after the third split we can be able to get the ascending order output. So it is showing the first split that's been done, then it is showing the second split that has been done, then after the third split we are able to get a sorted a monotonically increasing sequence with respect to this particular input as 5, 9, 10, 20, 14, 12, 8, 3. We are able to get this particular output. Now, now for the next one, if we will apply in this manner, then we can be able to get a reverse sorted output. Um, uh, we can be able to get a monotonically decreasing sequence. Now, these 16 values can be used uh, as a binary sequence, which can be given as an input towards the next stage, which can help in generating the required output. So in this way, if our input that as we have discussed into the older lecture, that if we have a sort Bitonic sequence, then on applying this Bitonic sequence, then on applying a Bitonic sequence in this form, we can be able to generate a sorted output. Now, now since this output is already into the ascending order, we can uh, with us with us with respect to any arbitrarily arranged input, if we will apply the same Bitonic merging operation repeatedly into the first broad stage, second broad stage, third broad stage, and this fourth broad stage comprising of four steps, then we can be able to get the required output into the ascending or descending order.